Okay, welcome back. We're looking at now calculating rates of reaction and being able to interpret rates of reaction graphs. The first thing to say about this is it's a very typical rates of reaction graph. You can see that there is a smooth curved line going all the way through, and then at the end here the reaction is finished. Commonly, there are 3-mark questions about describing the process of this or of this reaction. So what we can say is that in the first instance, between about 0 and say 14 seconds, the rate is quite fast. The gradient here is high, so a lot of gas is being produced in a short amount of time. So it is a fast rate of reaction. And as we move on, we can see that the reaction starts to slow down because less gas is produced in a longer amount of time, until finally at this point here, which is 90 seconds, the reaction has finished, no more gas is being produced. We can think about why this is happening. So at this point here, there are a lot of reactants that are reacting together. There are frequent collisions, as we've talked about before, with sufficient energy. As the reaction progresses, there are less reactants and there are becoming more products. So there are less frequent collisions between the reactants to make the products. And at the end, the only thing left in the reaction are the products. And so there is going to be no more of those made. So that is how we would describe and explain this curve that we see here on this graph. The other thing that we need to be able to do with the graph is to work out the actual rate of reaction itself, a numerical value. It's the quantitative side of the chemistry. So the first bit is how to work out a mean rate of reaction. Now this is very simple because we work out the gradient of this line, and many of you will be familiar with the term rise over run. So how much has it gone up by how much it has gone along. So this one is calculate the mean rate of reaction in the first 10 seconds. So we go to 10 seconds, we work out how far up it has gone using my scale, and then how far along, which I can see here is 10 seconds, and I divide the two values to get my mean rate of reaction. So here we've got to another graph with some same sort of thing on, but we're comparing here different concentrations of solution, concentration of acid, which it tells us here, and how quickly that they have reacted, the rate of reaction. And so we can see here that this 2 molar concentration has more particles of acid in it, so those particles are going to collide more frequently, and therefore the rate of reaction will be quicker. In point of fact, the rate of reaction finishes after 20 seconds. Next, we've got the 1 molar, and you can see there is still a fast rate, but it takes 42 seconds, 41 seconds to complete its reaction. And the 0.5 molar in 60 seconds has still not finished. We can make a prediction that it will get to about here at the top, which looks at about 62 seconds when that reaction will actually finish. So this is the data here that would show this steepness of this graph here would show that I am producing much more gas in a shorter amount of time, therefore the reaction is much faster. And I can use rise over run to work out the gradient of the graph. They're all fairly straight, so that means that I can just use my simple, take any point, rise over run, and work out the gradient to compare the actual rates themselves. Now, sometimes we'll be asked to calculate the rate at a specific time, and then this time here being T1, in some of the exam questions that I've seen, you'll be given an exact time from there. And at this point, you can see that it sits on a curve. So here we have to draw a tangent to the line and then make a triangle from that, using the same math skills, rise over run, to calculate it at this point here. Now, should you be asked to do this in an exam, you have to be very careful that the tangent is equal on either side of the line here. Excuse me. So the tangent is equal here and here, so that is the exact angle at which to draw the line.